other classes, I'll go over it, but it's already going to be filled out, but I'll walk you through it still. Okay, 13. All right, so I'm going to go to number 13. Guys. So that's telling you your center of dilation. Oh. When it says around the origin or about the origin, that means the origin is your center of dilation. Okay, but they're like the number 16 next to it, or no, not that one. Like 17 says about the point -62. That means that's the center of dilation. That's just another phrase for telling you what the center of dilation is. Yeah. All right. So in number 13, we have segment PQ. They give us the endpoints P and Q, and they say as a result of a dilation about the origin, that just means the origin's the center of dilation, so nothing fancy, just we just got to scale it. So after it's dilated, P prime has a coordinate of 6, -14. What are the coordinates of Q prime? So we have P and we have P prime. So we need to use those to figure out what the scale factor was, what it was dilated by. So I underlined the X's in red, the Y's in green, so you could see how do we get from 6 or from 2 to 6? Multiply by 3, right? Okay, how do I get from -7 to -14? Multiply by 2. Okay, and I know it's multiply because it says dilate. It's not asking adding or subtracting, it's dilate. So it's what are you multiplying by? So the X's are multiplied by 3, the Y's are multiplied by 2. So I take that original Q, the pre-image of Q, and I multiply the X by 3 and multiply the Y by 2 and end up with Q prime at -66.6. That makes sense? Yes, ma'am. Okay, what else? Okay, 23. All right, so 23 I also did in one of my other classes. So you can see I tried to highlight here to color code. You've got a nested triangle here inside the larger triangle. And so the 50 corresponds to side AB, which is what they're asking for. So I labeled that as X. Okay, and then on the sides, you could have done the bottom. I did the top because there was no decimals. Okay, but you could have done the bottom, the same thing. So for the small triangle, that's 71. For the large triangle, you have to add the 71 and 85, and you get that length of the large triangle is 156. So I set mine up, X is to 50 as 156 is to 71. Okay, you could have flipped that, or you could have gone X is to 156 as 50 is to 71, right? There's usually like 4 correct ways you can set up your proportion and still get the same answer. Do pay attention to rounding. It says round to the nearest whole number. Okay, so the nearest integer. And here that was 110. Once I solved that. What else? 24. I did 24 in my other class as well. So 24 is similar, except this time there's an expression, not just numbers. So the nested triangle, we know 5 and 25 are side lengths of that small triangle. And then the corresponding sides of the large triangle, I know the bottom is 16x minus 5. The side, I had to add the 2 pieces together. So when I add x plus 6 and 5, I get x plus 11. So when I set up my ratio, I did 25 is to 16x minus 5 as 5 is to x plus 11. And again, there's more than one way you could have organized that to set that up, but you end up multiplying 25 by x plus 11. So that has to be distributed in there. So it's 25x plus 275. And then when you cross multiply here, the 5 gets multiplied by the 16x minus 5. So 5 times 16, that's 80x minus 25. And then I did the algebra to solve for x. And the question asked for x. Okay, I don't have to go plug it back in and calculate anything. It just said, what is the value of x? Round to the nearest whole number again. So that was 5.45 repeating. So that is closer to 5 than 6, right? Okay. This page is almost completely done. Y'all want to go ahead and just knock this one out together, and then this page is done?
Yeah.
So let's look at 25. Okay, we've got a question saying, are the triangles similar? If so, by what theorem? So I've got nested triangles again, and this 90-degree angle marking is what's going to give it away. That's what's going to make me say yes, because I know the shared angle here at the vertex of both of them is going to be congruent to itself, obviously. Okay, but the fact that these other angles are also congruent because they're both 90, I can see in the small triangle, and I'll outline it if that helps you see it. In this small triangle, I've got these two angles that I know are congruent to those two angles in the large triangle. So I know two different angle pairs, two different corresponding angles are congruent. So I can say yes by angle, angle. And there's no work to show here. Okay, but knowing that two sets of corresponding angles are congruent proves similarity. Okay, that it's just knowing that theorem, angle, angle theorem. Now this one didn't have anything named, so we didn't have to write the similarity statement because we can't name them. There's no point naming any of those vertices. So, all right, what else? 27. All right. 27 was also a nested right triangle, similar to that one we just said would be congruent, or not congruent, would be similar, except they give us some side measures, some segment measures this time. They say CD is 4, ED is 9, and DA is 12. And we're looking for BE. So everything in black is what was given to me in the problem, the labels there. Now, they're asking us for BE, which that's not a side of a triangle. That's just this portion here of the large triangle side. But we know that when we have a parallel line cut through a triangle like ED is doing, and I know it's parallel to BC because these angles are both right angles. But when that happens, it splits the sides of the triangle that it intersects proportionally. So this BE is to EA as CD is to DA. Or you could write BE is to CD as EA is to DA. Either way. But we're missing two of those pieces. When we have a proportion, we can only be missing one piece. So that's what they gave us the 9 for here, is to help us find EA. Because this is a right triangle, this EDA, you know, two sides of a right triangle, you can find the third using Pythagorean theorem. So I set up Pythagorean theorem where A and B are the legs, so that's the 9 and the 12, and C is the hypotenuse, that's side EA. So I solved and got 15, so EA is 15. Now I have 3 of my 4 pieces of my proportion. So X is to 4 as 15 is to 12. Do you follow?
Wait, so you either or?
Either or what?
Like, you know how you do it?
I had to do Pythagorean theorem to get EA, and then I set up my proportion. You could have set your proportion up differently. You may have done X is to 15 as 4 is to 12 or something like that. But you had to do Pythagorean theorem to get this missing piece, EA, and then you had to set up your proportion. So this was multiple steps.
Okay. Sorry for a second.
No, it's all good. What else? Do y'all want to go ahead and do the rest on this page?
Yeah.
Okay, so let's look. I'm going to look at 30 right here. It says in triangle ABC, AC is 6 centimeters, angle A is 50 degrees, and in triangle DEF, angle D is 50 degrees, and DF is 9 centimeters. What additional piece of information is needed to prove that angle ABC is similar to triangle DEF? So I'm going to draw a picture, and your pictures do not have to be drawn to scale. So I'm just going to draw two triangles, and I'm going to name them ABC. And then we're trying to get enough information, see what we would need to prove ABC congruent to DEF. So I'm going to label it in that same order. So A corresponds to D, so D would be here, E, F. Okay, and then they told us D is 50, A is 50. So these angles are congruent, right? So we've got a pair of congruent angles. And then they tell us that DF is 9 and AC is 6. Okay, and those would correspond to each other the way that they wrote this. AC is to DF. So these would be corresponding. So what would the ratio be? What's the scale factor there? What is it? It's not what you add. Remember, scale factor is what you multiply by. Okay, so what would I multiply 6 by to get 9?
2/3.
Okay, so 3 halves, right? Going that way. Okay, so you can do 9 divided by 6 to go backward and get that scale factor if you need to. So if you need to show, okay, my scale factor is new divided by old. So I know the scale factor should be 3 halves. So to have enough information to prove that these are similar, I either need angle, angle, side, angle, side, or side, 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 right? So let's read through our choices. They say if the measure of angle B and E are 80 and 50 respectively. Well, if these are similar, wouldn't B and E have to be congruent? So no, that would not work. Okay, E and B would have to be congruent. So that won't prove them similar. Okay, then it says BC is 12 and EF is 18. Now, even if that's the right scale factor, okay, which it is, that's 3 halves is the scale factor there. That is not side angle side. Do you see how the two sides that are proportional, the angle that I know that's congruent is not in between those two sides, is it? Where the 12 and the 6 meet is angle C. I don't know angle C is congruent to angle F. So this is not side angle side. That's actually not enough information. Even though those sides are proportional, that's not quite enough information for me to say, yes, they're similar yet. So that doesn't work. And then the other option, C, says, okay, what if we said BC was 12 and DE was 18? Well, those don't even correspond to each other, do they? BC and DE. So that's not going to work. They don't correspond. That's not helpful at all. And then it says, D says, okay, what if we said the measure of angle B and F are 80 and 50 respectively. So right now we know 50 and 50 respectively means in that order. So they're saying B a different color here. Since B came first, they're saying B would be 80 and F would be 50. Now those don't correspond, which is fine because they're not saying they're congruent, are they? But let's see if that would work. If we have two angles of a triangle, can't we find the third because they have to add to 180? So what would angle C have to be if angle B was 80 and A was 50? This would have to come out to be 50. Okay, if these were both 50 down here, what would angle E have to be? It would have to be 80 because of triangle sum. Now, is that enough to prove these are similar? If you have multiple sets of congruent angles in a triangle, yeah, by angle. Angle theorem proves similarity. So knowing that piece of information that D told us, that would prove those are congruent, or excuse me, not congruent, similar. The angles are congruent, the triangles are similar. All right, let's go ahead and take a look at 28. 28 says, which set of triangles is similar? So again, you look at their respective way that their sides are listed, and then we're going to check those ratios. Okay, so I'm going to check 12 would be to 6, as 16 is to 9, as 20 is to 10. Okay, so if I look at that, 12 over 6 is 2. 20 over 10 is 2. But is 16 over 9 2? 16 divided by 9 2? No. So those are not similar because all of the sides have to be proportional to prove the triangles are similar. Okay, so in B, I would check 8 is to 16, as 15 is to 30. So far, so good, right? 1/2, 1/2. Okay, and then 17 is to 34. Is that 1/2 as well? That one works. So those are similar. I don't know if this is a multi-select or not, so let's just check the others to be safe. So for the C, I would check 9 is to 8, as 12 is to 16, as 8 is to 24. None of those are the same. Not equal. And then last but not least, I would check 4 is to, I think those extra lines, 4 is to 6. That's 2/3. As 6 is to 9. That's 2/3. As 14 is to 21. That's 2/3. So does that one work? Those are all similar as well. Okay, so this one also checks out. Okay, and again, guys, y'all get y'all's scientific Desmos, so you can use that to check these and just like check they're all the same decimal, they're all whatever the ratio is. Okay, so that one checks out because they are all 2/3. B checked out because they were all 1/2. Good. All right, in 31, it says triangle PQR and triangle WXY are similar. So we're told they are similar. The measure of Q is 135, PR is 45, and WY is 9. What is the measure of angle X? There is extra information here you don't need. Y'all had one on the quiz like this where a lot of y'all got caught up on the extra information. If it's not needed, don't worry about it. Look at, we are told that they are similar and we're given the statement so we can see where the Q is in the middle, right? So what does it correspond to in the other triangle? X. So Q and X have to be the same. And they tell you Q and ask for X. So your answer is simply 135. That other information is just extra information. right? And then I did those in another class. Okay, so that page is done. Yeah. Does anybody else have a specific question they want to go over, or should I just find ones I haven't done? Okay, let's look at 19 then. So 19 says DF is parallel to CG. So I know when we have a parallel line cut through a triangle, it divides the sides it intersects proportionally. Okay, so 40 is to 30 as GF is to 42, right? They want us to find the length of GF. I'm just going to call it X. Okay, but those are proportionally divided with the parallel side. So you could do 40 is to 30.
Wait, can you also do 40 and then do 30 on?
You could do 40 is to X as 30 is to 42.
Okay, I thought.
Yep, those are both correct. You could set it up either way, okay, or you could flip, but if you flip both, that's fine too. So I could do 30 over 40 and 42 over X, or X over 40 and 42 over 30. Okay, so it doesn't matter how you set, there's, like I said, multiple ways to set up your proportion, as long as you end up multiplying 40 by 42 and dividing by 30. And that comes out to 56. Now, did the question simply, X was representing GF, is that what they asked for? Yeah, right, isn't it? Yeah, so we're done. We don't, if they had asked for GE, we would have to add those together, right? So you just pay attention to what they're asking for. But in this case, it's simply 56. Did those. All right, let's look at 20 and 22 then. Okay, so in number 20, given triangle BAE is similar to triangle CDF, what is the length of DC round to the nearest whole number? Now, I like to mark, I think for some of you, it's helpful to mark the congruent angles because they tell us the order. B corresponds to C because those are the first ones. So B and C are congruent. Okay, A corresponds to D. So A is congruent to D. And then E corresponds to F. So E is congruent to F. Okay, so if that helps you see those triangles better, and you can separate, if you don't like having that little bit of overlap, if that confuses you, draw them out separately like this and label them. That's fine too. So if I were to do that, let's look at this. If I did, this would be A, B, E, and this would be D, F, and C, right? So if I were to separate them out, let's get this length over here is 45. Let's look at the bottom. BE. How long from B to E? What do I have to do there? B to E. I'd have to add the 82 and the 41. So 82 and 41 is 123. Okay, and then I'd have to do the same thing for C to F. So I'd have to add the 41 to the 38 and see that that's 79. So if you need to separate them to get a better visual, then do that. Separate them. So then they ask us to find DC, which is here. So now it's easier for me to see my ratio. Again, I can do 45 is to X as 123 is to 79. Or I could have done 45 is to 123 as X is to 79. Okay, either way, I'm multiplying 45 by 79 and dividing by 123. And then it says round to the nearest whole number. So this comes out to 28.902, it keeps going. So what is the nearest whole number? 29. Okay, and this is DC. All right, on 22, we've got the parallel markings on the top and bottom sides of those triangles there. It says, what's the value of X round to the nearest whole number? Now, because these are parallel, I know the triangles are similar because parallel lines and a transversal tell me the alternate interior angles are congruent. So I know these are corresponding angles that are going to be congruent in those triangles. And then obviously the vertical angles in the middle are congruent to each other. So putting those markings there sometimes helps you identify which sides correspond. So for instance, the 2x minus or 2x plus 5, that connects a red to purple. So in the other triangle, the red to purple is 20. So those are going to be what correspond to each other. So the 2x plus 5 is to 20. And then 3x plus 1 is going to correspond to the 26 because they're both between the blue and purple angle markings that I put. So 26 is to 3x plus 1. So I'm going to set up my proportion. And because we have expressions, pay attention, make sure you visualize or put those parentheses in there so that when you cross multiply, you distribute. So that 26 has to get distributed. So 26 times 2x is 52x. And 26 times 5 is 130. And then this 20 has to get distributed. So 20 times 3x is 60x. And 20 times 1 is 20. Then I'm going to solve. So I'm going to move my x's to one side. I always like to move the smaller one to be left with a positive. So that leaves me with 8x on the right. And then I'm going to move my constant to the left, minus 20. So that leaves me with 110. And then I've got to divide out the 8. So 110 divided by 8, and it does again say round to the nearest whole number. This comes out to 13.75. So what's the nearest whole number?
14.
So, and it's, are we looking for just X, or are we supposed to be finding a segment length? What are we doing?
X.
Just X. Value of X. So the nearest whole number is 14. Okay, so make sure you're reading carefully and going back and double checking that you've answered what the question asked. Gunnar? Mm-hmm. Good. What did I what? For number 19 or 21? What are we looking at? I could do it that way if I wanted to combine these and look at this side as a whole. Okay, I could do 35 is to that sum as 33 is to this sum, and that would work as well. But I don't have to because these are parallel. It splits it proportionally. So I don't have to do, that's just an extra step I don't have to do, but you would get the same answer if you did that correctly. Uh-huh. All right, let's see what else we've not answered. 20 came out to 29 was the nearest whole number.
Oh, okay.
Let's look at 14. So in number 14, I've got an angle bisector. Guys, this does not, X is not 15. These are not equal. It's not bisecting the side. Okay, it is bisecting the angle. When you have an angle bisector, it splits that side proportionally. So I can say x is to 14 as 15 is to 21. Okay, so I would end up multiplying 15 and 14 and dividing by 21, and that comes out to 10. I already did 17 in another class. So let's look at 15 and 18. In number 15, it says a line segment XY has endpoints X and Y as a result of the dilation. Okay, so this is similar to another one that we did. I did in another class, so I'll do one with y'all. So I know the original X and I know X prime. So I know the pre-image and the image here. I need to figure out the rule, and it tells us this was a dilation. So that means if I multiplied by something, some scale factor. So I'm trying to figure out what that scale factor is. So how did 3 become 9? What did you multiply? 3 times what is 9? 3 times 3. Okay, so 3 is being multiplied by x. Okay, so the rule we're coming up with here, the x gets multiplied by 3. What about the y? Also multiplied by 3. So this one had the same scale factor for both the x and the y. Okay, so then I'm going to take my original y and to get y prime, I would apply that rule. I'd apply that scale factor of times 3. So what is -6 times 3? And what is 5 times 3? So that would be my new y prime. Okay, that's a basic dilation. We just figure out the scale factor and then apply it. Now 18 is not a basic dilation. This is one of the ones, again, that is dilated around a center of dilation that's not the origin. Okay, so you notice how this last one said about the origin? This says about the 0.30. So this means this is my center of dilation. So we've got a couple of things we could do. We could do this graphically, which like 95% of y'all preferred graphically. Okay. Now you do not get Desmos graphing. You get Desmos scientific, but I'm going to show you on graphing what I would do. And you just do it on graph paper. Like you would do this on your paper. Okay. So the point that I am trying to dilate, point A is at -6, -3. So I would plot the point -6, -3 and label it point A. And then my center of dilation is at 3, 0. So I would plot that point as my center of dilation. Then once you have these, you count the distance horizontally and vertically between your center of dilation and your point. So vertically, these are 3 apart, right? Y'all agree? Okay, and horizontally, 9. Y'all agree? So from the center of dilation to A, I go left 9, down 3. Left 9, down 3. Could write that down. Okay, so you could say from the center of dilation to A is left 9, down 3. Now I need to scale that. That's my K. So I need to multiply by my scale factor. So what does that become then? Left, what's a third of 9? 3. And what's a third of 3? 1. So instead of left 9 down 3, I'm going to go left 3 down 1 from the center of dilation. So if I go left 3 down 1, where does that put me? That ordered pair. 0, -1. So my answer would be 0, -1. Okay, that's graphically. You could have also done this the algebraic method where you shift your center of dilation back to the origin, then scale, then shift back. Okay, I did number 17 that way. If you want to go back and watch the video for that later, you can do that. So I did, yeah, 17 algebraically, and I think I showed it graphically as well in the video. And then this one I just did graphically because I think the great majority of y'all prefer graphically. Okay, so I think that page is done. So let's flip back. Let's look at 9 and 12. So here on 9, we're told that DE is half of AC. Oh, let me grab the phone. Hang on. Yeah. Okay, so they tell us DE is half of AC, which statement is not true. On the quiz, a lot of y'all didn't read carefully and you didn't read the word not, and you just picked the first thing that was true. Okay, so 3 of these are supposed to be true and 1 is not true. So it says, can y'all please stop the side conversations? We're almost through. Okay, the triangles are similar because DE is a mid-segment of ABC. Yeah, when that relationship, for that to be half of this length, these must be parallel, and this must be midpoints. D and E must be midpoints. So that's a mid-segment. So that's true. If that's a mid-segment drawn, you're creating a nested similar triangle. Okay, the triangles are similar because they share a common angle at vertex DBE. So this 57-degree angle is a part of both the small and large triangle. And angle BDE, so this 30-degree angle, is congruent to BAC. This is 30 degrees. That's true. And angle is enough to prove similarity. So that is true. Okay, the triangles are similar because their corresponding angle pairs are all congruent. These are not marked, but using triangle sum, we could figure out what that angle must be, and they would come out congruent. So that's also true. So why my pen stopped working? Okay, and then the triangles are similar because they're corresponding side lengths. Like we know nothing about side lengths, so that is obviously not true. Okay, so it was D. D is the one that is not true. All right, in 12, find the value of X. The answer is not a whole number. Let's simplify. This is geometric mean. Again, the value of X is a leg in this one. So the leg rule says that the leg squared is equal to the product of the part of the hypotenuse that it's on the same side as. So that's the 6 times the whole. I'll post this after school. So 6 times 13 and a half. So 6 times 13 and a half is 81. And then to get rid of the square, you would take the square root. That is a perfect square, 9. So we didn't have to do a factor tree to simplify here. That was just your answer. Okay, and then let's see. Did I answer everything? Oh, there's just 2 left, but I'll post, so the videos go over everything but these 2. So if you have questions on anything else, they're in one of the other videos. Except for these, I might make a separate video after school just to go over those 2 to make sure everything's covered. What's up?